All right, welcome everybody to our first Trig PreCalc video of this session. I saved us a little bit of time by typing this out beforehand, so we can kind of just talk through it. Today, we're going to be focusing on graphing and finding inverses. For you avid kiddos out there, essential question, how do we graph and find the inverse of a function? So when we're talking about inverses, this is actually going to give us a flashback to our IM2 days when you take the x and the y and you flip-flop them and solve for y. That's what we're doing, a little bit more advanced examples of those, but nothing too crazy today. All right, so the initial thing when we're graphing inverses, and we've already previously talked about one-to-one functions. When these one-to-one functions and their inverses are symmetric to the line y equals x, then well, they are inverses of each other. Okay, these two need to be reflected or symmetric to the line y equals x. And when we're talking about that, if we set it up in mx plus b form, in y equals x, the b is 0, we don't see anything. And the m, we don't see either, but since it's multiplied, it needs to be a 1 over 1. So just quick review, if we were to graph that, basically y equals x is just the diagonal line that crosses through the origin. Right, so it starts at 0, that's my b, and then up 1 over 1, up 1 over 1, and then the same thing in the other direction. Okay, so it's just the diagonal line that crosses through the origin, y equals x. So everything that we have and is invertible is going to be reflected over this, or symmetric over this line. So first example, so we are able to reverse the roles of x and y in order to find an inverse. Right? Flip-flop x and y sounds familiar from our IM2 days. That being said, let's take an example just based on points. So we're going to want to go ahead and find the inverse of the following set of points. So let's take -2, -1, -1, 0, and 2, 1. So this is the original. All right, so just 3 points. This is the original problem here. All right, they want us to find the inverse. And up here it says that we can reverse the roles of x and y in order to find the inverse. So our points are made up of x and y. So the inverse that we should be able to find, all right, so let's go ahead and find the inverse. It should be those same points, but just with their numbers flip-flopped. So the inverse of the first point would be -1, -2. And the next one would be 0, -1. And the last one would be 1, 2. So we're just taking all those points and flipping them. So let's see what this actually looks like once we graph it. All right, so we're going to graph the original and the inverse on the same graph and see how they are reflected of each other. All right, so our original points, I'm going to do this in red. So -2, -1. So back 2, down 1. -1, 0. That's back 1, and then no up and down. And the last one is 2 over and 1 up. So we don't have a lot of points, but we can connect these just kind of generically, like so. I can do better. Oh no, made it worse. Yeah, we'll just roll with it. All right, for the inverse points. Now, pause for a second and show us that y equals x line. Remember, it's just a diagonal line throughout here. So the next set of points should be reflected nicely over this, or symmetric over this y equals x line. Let's find out. So the inverse point, we're going to go ahead and do in green. We've got -1, down 2, 0, -1, and then 1 up 2. And connecting all these points together, boom, boom. And look at that, we have a nice reflection from the red line to the green line nice reflection over this y equals x line. All right, and that's what we were looking for. So these are inverses of each other. It's a one-to-one function, so they should be able to reflect or be symmetric across this y equals x line. All right. So that's given points. Let's say we're given an actual equation. So this is our flashback to I am 2 days. So for example, find the inverse of, and our equation this time is going to be f of x equals x cubed minus 1. All right. So again, take x and y, flip the order of them, solve for y. Remember, f of x, that's just the same as y. So we can replace it. Y equals x cubed minus 1. We're going to take the x and the y. Remember, they're interchangeable when we're finding inverses. We can flip them. So we've got x equals y cubed minus 1. And now the name of the game is isolate y. So I want to solve for y. All right, first step is add 1 to both sides. X and 1 don't really combine together, but we can just write it as x plus 1 equals y cubed. Now if that was squared, the way we'd get rid of it is square root it, but since it's cubed, remember the wording to get rid of that is cube root. So the cube root and the 3 cancel each other out. But what I do to one side, I do the other, and I've got to do it to the whole other side. So we've got the cube root of x plus 1. So in the end, y equals the cube root of x plus 1. So just making sense of things. Up here, this is the original function. Down here, this is the inverse. All right. Now the cool thing we're going to see is, remember, graphing both of these, we should be able to see that the original and the inverse will be reflected over that y equals x line. So let's put some marks on here. I'm going to put the y equals x line on first. Remember, it's just the diagonal. Ooh, pretty good that time. So that's our y equals x line. And now flashbacks. All right, so the original graph right here is y equals x cubed minus 1. And if we remember from what we learned earlier, biggest exponent is 3. That's odd, so the arms are going opposite directions. And the first term, a, is positive. So this should be going from low to high. And if we think back to our I am 3 days, -1 means this is a vertical shift, and -1 downwards. So its starting point is going to be at -1. If you set it equal to 0 and solve it, you'll find that there is an x-intercept at +1. Arms are going from low to high. So there's our x cubed. We also want to be able to graph the inverse. Okay, I'll do that one in pink. Cube root. Thinking back to our I am 3 days. Cube root and cubed functions, they're very similar. It's still going to be that snake shape from low to high, but now cube root is laying off to the side. Now this does have a little bit of horizontal shifting. Okay, so remember we take this out of here, that's going to be a -1. So it starts at -1 and has a y-intercept at +1. Remember, this is going from low to high. It's kind of like a sideways snake shape. And if we see these, they should be pretty good reflections of each other. All right, so reflected over this line, symmetric across this line, x cubed and cube root of x. All right. One last example for us. This one we're going to focus more on just finding out what the inverse is, but a bit more complicated process. So again, let's find the inverse of, here's my equation. All right, find the inverse. F of x equals 2x plus 1 over x minus 1. So again, the general idea, switch x and y, isolate y. The only problem is here we've got a rational equation. So rationals, remember, we're going to run into domain issues later. So let's make a note of that later on. And also they're going to ask us about range issues. Okay, so we're going to look at the domain and the range in the end. So I'll make a note of that for later on. Alright, so first things first, f of x is the same as y. So I'll just rewrite that. Next step, take x and y and switch them. But if you notice, I've got two x's. So meaning when I switch them, I'm going to end up with two y's. So x equals 2y plus 1 over y minus 1. A couple different ways to do this. Eventually we're going to have to get all the y's together and make sure there's only one y in the end. Just looking at a rational here, we want to break up that fraction. This whole thing's grouped on the bottom. So I can multiply by that same thing because that will cancel out the y minus 1 and that y minus 1. But what I do to one side of the equal sign, I have to do the other. So we multiply out this side. We get an xy, interesting, minus an x equals 2y plus 1. Eventually I do need to get all the y's together and all the other terms on the other side. So I'm going to go ahead and move this 1 first by subtracting it. Move it to the other side. It has no other like terms, so it's just going to kind of move and sit over there. So xy minus x minus 1 equals 2y. And again, you notice we have multiple y terms. So let's get all those y's together and see if we can do something with it. So the way we do that, I can't just break off that y. I want to move the whole term. So I'm going to subtract that xy piece to the other side. Doesn't have a like term, so it's just going to move. So we've got negative x minus 1 equals 2y minus xy. And it really looks like we've just made a mess of things. Again, I want to get y by itself. Problem is there's two y's. But if we look at this piece as a whole, is there a way I could pull a y out of that? Maybe thinking about our GCF methods, factoring out a factor. So I am able to pull a y out of both, and that leaves me with, let's see what's left, 2 minus x. On the left-hand side, still x, or negative x minus 1. And then notice this, we still want to get the y by itself, and it's attached to the rest of that with multiplication. Opposite being division. So I'm going to divide by 2 minus x, makes those cancel. But what I do to one side, I should do to the other. So in the end, it looks like we did get y all by itself now. So I'm going to write that y here. We've got negative x minus 1 over 2 minus x. Y is by itself. This is the inverse of the original problem. So here's the inverse. All right, back up here. Let's find the original. There it is. There's the original. So we're not asked to graph these ones, though we do know how to graph rationals. But we are going to look at the domain and range of these. So, domain. Remember, we find domain, or domain is all real numbers for these rationals except for some problem numbers, and those problem numbers show up on the bottom. Remember, we can't have 0 on the bottom of a fraction. That makes it, what's the word? Oh, I forgot the word. what the world? Undefined, that's what it, why did I go blank? Undefined, 0 on the bottom is undefined. Anyways, so anywhere there's a 0 on the bottom, we cannot have that in the domain. So basically just set this equal to 0. Whoops, right in the weird thing. So set this equal to 0 and solve it. So anywhere that we plug in a 2 is going to give us an issue. So remember, we write that out. X is all real numbers except for 2. We can't have 2. Now something we haven't really looked at too much is range. Alright, but this is actually pretty easy. And we're going to make a little note underneath just because this might be the first time we're seeing it. Range is the same as domain. So the range is domain of f of -1 of x, just with the y values. Okay, so f of x, remember, is just, or f of -1 of x, that just means inverse. So the range is going to be the same as the domain, but instead of x's, you're going to write y's. That's just the big difference there. Okay, so in this case, range is measuring the y values, and we still can't have anything equal to 2. Alright, so domain and range are going to be the same. Domain with the x's, range with the y's, and that's that. But again, I'm more focused on us being able to get the actual inverse function. Domain and range kind of fall into place because we reviewed that stuff before. Alright.